So this is the second of my videos on energy resources. Previous one we looked at renewable resources. Now we're going to look at non-renewable sources. So what you need to know, we're going to be describing, comparing and evaluating different non-renewable energy resources. We're going to understand by the end of it that some resources are more reliable than others, and therefore the mix of resources that are required. We'll look at a 6 marker at the end of this session, bringing all the ideas from the 2 videos together. So we've looked at this slide before, but really important to understand what a renewable energy resource is. It is one that will not run out and can be replenished in a short period of time. So examples, like hydroelectric, wave, tidal, solar, we've looked at those in the previous video. But also the main advantages of them is that they don't produce greenhouse gases or acid rain. Avoid saying they don't pollute, okay? Be more specific, talk about greenhouse gases, carbon dioxide, acid rain, sulfur dioxide. Non-renewable energy resources are sources that are finite. They cannot be replenished once they've been used. They will run out. And those, of course, coal, gas, oil, uranium, as are all non-renewable energy resources. Most of them, not the uranium, but the coal, gas and oil also produce greenhouse gases, acid rain. Obviously, the uranium produces radioactive waste. So what are fossil fuels? Well, fossil fuels are organisms, trees, plants, microorganisms from the oceans that have died millions of years ago. Okay, coal has come from plants and trees. Natural gas and oil have come from these microorganisms, mostly in the ocean. It's taken millions of years, but they are very, very carbon rich. This carbon, we can burn that carbon, producing lots of heat energy. That in turn, as we talked about in the previous video, can cause motion. Okay, if we can cause water to boil, produce steam, then that kinetic energy that's produced as a result can turn turbines and turn electrical generators. So the energy changes here. We start with coal, oil or natural gas. They contain that carbon, they contain that chemical energy within them. We burn that and it turns into thermal. Then that thermal energy is used to boil the water, turns the kinetic energy, that steam is forced through into generators and turbines. The generators will then produce electrical energy. So here's a sort of gist of it. Anything that you've got here, you're going to burn this coal here, produce heat, heating the water, and that's going to cause these turbines and generators to turn, and the generator then produces electricity. So the main problems with fossil fuels, this goes for all of them, the coal, the oil, and the natural gas. They are polluting, but we need to be more specific, as I said. They all produce carbon dioxide, which I'm sure you're aware is a major greenhouse gas and causes climate catastrophe, global warming. They can also produce sulfur dioxide, which can cause things to dissolve, so buildings to dissolve, or it can be really bad for trees, damages buildings, damages forests. Also, a major thing, they are not renewable. We defined that earlier, so we know that renewable means they can be replenished, but non-renewable, they cannot be replenished, therefore they're going to run out. Estimates between 50 to 200 years. We are finding more reserves fairly regularly, so probably closer to the 200, but ultimately it will run out eventually, and we are using energy more and more quickly. So here's the main advantages. They're very dense. They produce a lot of energy. They're reliable. You don't have to worry about whether the wind is blowing, whether the sun is shining. You can turn them on and off whenever you want, and they can be built anywhere. You need to think about whether a thermal power station is close to a river, like an HEP power station might need to be. It needs to be by a river that's appropriate for that hydroelectric power to be turned into electricity. And for these fossil fuels, we don't get radioactive waste. But, of course, there are some downsides, which I've already mentioned. They are non-renewable. They will run out. They produce greenhouse gases, which contributes to global warming, climate catastrophe, and also potentially acid rain. Some are cleaner than others, but acid rain is fairly common as well. So the next one, nuclear power. The process is the same, okay? You're using forms of uranium, isotopes of uranium, to produce heat. Don't forget, the process is the same. We need to produce heat That heat in turn will heat up water. That water turns into steam. That steam is forced through a turbine, and that turbine turns a generator. The generator produces the electricity. So here we are. I've said it already, but this is the heat energy is used to produce the steam. The steam drives the turbine, which creates the electricity. So in this case, the energy changes very similar, but we're not starting with chemical energy. We're starting with nuclear energy. Heating up, thermal energy, boiling the water, causing that steam to move the turbines into kinetic energy, and that kinetic energy turned into electrical energy. We will look at more detail of this when we look at radioactivity, which is another topic, a whole big topic. We'll come back to this idea of nuclear fission and nuclear fusion. But this is a nuclear fission reactor as an outline of it. But generally, as I say, heating up water, turning a turbine, turning a generator, producing electricity. So the problems with nuclear power stations, they don't necessarily produce greenhouse gases, and they are very, very energy rich. Okay, they're very dense. They can produce lots and lots of energy, but they do produce radioactive waste, and this needs to be stored safely. That's difficult because the radioactive waste lasts for long, long time, thousands of years, potentially giving out dangerous radiation. So you need a way of storing that in a way that's going to be safe. Obviously, as we use it more and more, there's going to be more and more of that waste. Although it's safe normally, accidents can happen, and when they do happen, they tend to be fairly catastrophic, fairly large. There really haven't been many disasters, but when they do happen, we know about them for sure. People worry about that. So Chernobyl is the absolutely most famous one, 1986, and the area around Chernobyl still cannot be inhabited, still closed off. So radioactive. So advantages of nuclear power, very dense. Again, reliable, just like coal and fossil fuels. We don't need to be in the right place for them to be working. We don't need the sun to be shining. We don't need the wind to be blowing. They can be built pretty much anywhere within reason. No greenhouse gases and no acid rain. But the disadvantages: non-renewable, radioactive waste, and they are very expensive. I hadn't mentioned that, but they are expensive to build. So what I've got here, I will put these as a separate download, but this is just a nice little summary, hopefully, of renewable and non-renewable resources, and a little practice question to see what your understanding is. Have a go at that and stop the video. And the answers: most of our electricity is produced by thermal power stations. What I mean by that is coal, nuclear, oil, and gas. These use the heat produced by burning or the fission of burning fuels or the fission of uranium to generate electricity. The heat produced is used to change water into high pressure steam. This steam is used to turn a turbine, which in turn rotates an electrical generator. Over 40% of our electricity is generated by using thermal power stations. Interestingly, when I first made this PowerPoint, that 40 was about 90. Okay, in the 90s, 90% of our electricity was produced with thermal power stations. In the last 5 years, that's changed considerably, but we were around the sort of 60% for quite a long time. Okay, so here is an example question of the sort of thing you might be asked. We've talked about lots of ideas in the last two videos, but this is quite a nice question to end on. So compare the advantages and disadvantages of renewable and non-renewable energy sources for generating electricity. Use examples in your answer and explain why a mix of energy sources is often used in modern energy systems. So what do they mean by that? Well, it's actually mentioned in a few specifications, this need for a mix of energy sources. What we're talking about is, can we just rely on one form? Can we just rely on one resource? Can we just rely on wind power? Well, hopefully you're aware, as we've mentioned, sometimes it's windy, sometimes it's not. Wind is a great resource because it doesn't cause pollution, but it's not always windy. And so we can produce lots of wind farms, but what's going to happen when it's not windy? Well, you're going to need a backup, and that's what this mix is all about. So have a go at that question. See the sorts of points that you're going to need, and I will go through it in a second. So here are the answers. Here are the points you might want to have made. This is the suggested mark scheme. First of all, define renewable and non-renewable resources. So they're asking you to compare the disadvantages and advantages of them. So first of all, what are they? Provide one example of each of them. Provide an example of renewable, e.g. wind and solar. Provide an example of a non-renewable, e.g. coal and gas. And then an advantage and a disadvantage of each. Advantage and disadvantage of renewable, advantage and disadvantage of a non-renewable, and then explain somehow, which I've just touched on, why a mix of energy resources or sources is beneficial. So here's an example of what the sorts of things you might want to write. Energy resources, we've already mentioned the wind and the solar power. The advantages here, they are sustainable, they do not run out, they will not produce greenhouse gases during operation. The disadvantages, however, they are unreliable due to dependence on the weather, e.g. cloudy for solar, or if it's not windy enough for the wind power. For non-renewable, what are advantages and disadvantages? Obviously, there's your examples, and your advantages are they're reliable, you can turn them on, you can use them whenever you want, whenever electricity has demand. High energy density, so small amounts generate a lot of energy. But the disadvantages, as I'm sure you're more than aware now, release significant amounts of carbon dioxide, which contribute to global warming. They are finite, they will eventually run out. So the last part of that question, as I hinted at, why a mix of energy sources is used, why is it necessary, why will all countries need a mix? Well, we need to balance the environmental benefits with reliability. We want to reduce emissions, we want to reduce carbon dioxide, we want to reduce sulfur dioxide, but we also need a reliable source. So what we can do is we can have our wind power stations as our mainstay, but if there's a surge in energy requirements, we can use a backup of coal. Not all the time, we don't want to use it all the time, but we want to use it when we need it. So coal, gas, nuclear, or oil. So, for example, a country might use solar or wind power but rely on gas-fired power stations during a calm or cloudy period, or if there was a sudden surge. Okay, so what we should know, you should be able to name 4 non-renewable energy resources, describe how non-renewable thermal power stations produce electricity and the energy transfers involved. You should be able to describe and compare and evaluate the main non-renewable energy resources, the pros and the cons, and explain why a mix of energy resources is required in modern systems such as the national grid. The national grid, of course, being the UK's energy system. Okay, I hope you found that useful, and I look forward to seeing you soon. Bye-bye.